trig identities. To start, I'm going to go through the warm-up problems. These are the problems that we did yesterday, so it's using identities to simplify. Please follow along as I write out the solutions. Now we're going to learn how to establish identities. And establishing identities means to start with one side and use the appropriate basic identities that we learned last class and basic manipulations to arrive at the other side. This means that you're going to have expressions such as f of x is equal to g of x. And without changing sides of the problem, so without adding or subtracting, multiplying or dividing from one side to the other, you need to prove that either f of x is equal to g of x, so prove that you can get f of x to the solution of g of x, or prove that g of x will equal f of x. So work one direction or the other. And that's what establishing identities is. Looking at number 1, we have cosecant of theta times tangent of theta is equal to secant of theta. So what you want to do is you want to start with the more complicated expression. That's going to be the easiest way to prove your identity. Okay, so starting with cosecant of theta times tangent of theta, I'm going to create or change both of these identities to sine and cosine values if possible. So cosecant becomes 1 over sine of theta, and tangent becomes sine of theta divided by cosine of theta. And this is equal to secant of theta. So I am only working with the left side of the equal sign, and I'm trying to prove that the left side equals the right side of the equal sign. So writing out what I just did, I can quickly eliminate my sine value in my numerator and my denominator. This leaves me with 1 over cosine is equal to secant. And 1 over cosine is a reciprocal identity that we learned about last class. So this reciprocal identity, 1 over cosine, is equal to secant of theta. So at this point, we can prove that secant of theta is equal to secant of theta. And that's what you're doing when you're establishing identities. You're proving that one side, typically the more complicated side, can be manipulated and set equal to the other side of the equal sign. And that's what we did. When we arrived at our final answer, we can see that our original secant of theta remained in the problem the whole time. So it will be tempting to add, subtract, multiply, divide to either side of the equal sign in order to solve faster, but that is not what trig identities are. So trig identities are proving one side equals the other. That means you should not be using cross multiplication or any of those previous concepts that you've learned. Over here, I just included a study tip, and it says that verifying an identity is not the same as solving an equation. So basically, this is what I've been talking about. When verifying an identity, you should not use any property of equality, such as adding the same number or expression to both sides. You simply need to just simplify one side of the equal sign. Okay, number 2 is 1 plus tangent of theta divided by cotangent of theta is equal to tangent of theta. And I'm going to simplify the left side of the equal sign again. That's definitely the more complicated side. But I'm actually going to approach this one different than I've done other ones. So previously I've been converting everything to sine over cosine, which you can absolutely do. But in this problem, because I already see that I have a tangent value, I'm going to convert cotangent to its reciprocal identity of 1 over tangent. And you don't have to do this. You could definitely do this different than how I am. But I'm going to convert this expression to 1 plus tangent of theta divided by 1 plus, instead of cotangent of theta, I'm actually going to write 1 over tangent of theta. And this was one of the identities that we learned yesterday. And this is equal to tangent of theta. Now I'm going to add the denominators together so I can create one single denominator. So in this denominator, in order to add these together, my first expression, which is 1, is going to have to now have a denominator of tangent of theta, which means I also need to multiply the numerator by tangent of theta. My expression becomes 1 plus tangent of theta divided by my new fraction of tangent plus 1, or tangent theta plus 1, divided by tangent of theta. And that's just from adding my numerators together and then creating a common denominator. And we're proving that this is equal to tangent of theta. Now, once you get to this point, you can multiply by the reciprocal. In order to multiply by the reciprocal, the first fraction, or the numerator, becomes 1 plus tangent of theta, Technically, this is over 1. I'll just write that so we can keep it organized. And the second fraction, I need to flip, becoming tangent of theta divided by tangent of theta plus 1. And we're proving this is equal to tangent of theta. Now you should be able to see that 1 plus tangent or tangent plus 1, however you write it, those are the same expression, so we can eliminate those, leaving us with just the numerator of tangent of theta. And this is equal to tangent of theta. So we just proved that we had identities within this problem. Now you could have gone about number 2 by creating every term to sine and cosine. It would have created a longer of a problem because you would have had to create common denominators and add and subtract in both the numerator and the denominator, but you would have arrived at the same answer. It would have just taken you a bit longer. So if you're confused how I knew to stick with tangent, don't worry about that. Go right back to your sine and cosine properties and solve from there. Number 3, we have tangent of theta plus cotangent of theta divided by secant of theta times cosecant of theta. So I need to simplify the more complex part and prove that it equals the other side. To start with this one, I'm going to convert everything to its reciprocal identity. Tangent is going to convert to sine divided by cosine. Cotangent converts to cosine divided by sine. This is all divided by secant, which converts to 1 over cosine, multiplied by cosecant, which is 1 over sine. So in the numerator, I need to add these expressions together. And in order to add these expressions together, I need to create a common denominator. To create the common denominator, I'm going to have to multiply each expression by the opposite denominator. The first expression will be multiplied by sine of theta, and the second expression is going to be multiplied by cosine of theta. In the denominator, I'll be able to just multiply these together in one shot because it's already multiplication. So my new numerator becomes sine squared theta divided by cosine times sine plus cosine squared theta divided by cosine times sine. This is all divided by our simplified denominator, which is when we move or multiply the denominators together, and that gives us 1 divided by cosine times sine. And this is all equal to 1. Next, I'm going to add my numerators together in the numerator up here, leaving me with the expression of sine squared plus cosine squared, which is going to be a Pythagorean identity, divided by cosine times sine, all divided by 1 over cosine times sine. Now this right here is going to be a Pythagorean identity. And the Pythagorean identity says that sine squared plus cosine squared is equal to 1 squared. And within this step, so obviously I'm going to replace that with 1, but it's also division, so I know that I can multiply by the reciprocal. So I'm going to create a first fraction as 1, replacing sine plus cosine squared. So 1 divided by cosine times sine. And I'm going to flip the second fraction. And this is going to become cosine times sine divided by 1. Here you can see that your cosine and sine values are going to be eliminated, leaving you with the fact that this is 1, and we were proving that it is equal to 1, so we just proved our trig identity. And that's your final answer. Okay, it's a good idea to make notes throughout your process, especially when I'm checking over your work, just so I can see what you do. Everyone could be solving these differently, so if you make some notes, like for example, when you use your Pythagorean identity or when you use a reciprocal identity, I'll clearly be able to see what your final answer is and how you got there. You're probably not going to have the same answer as somebody else in class, so it does take a while to go through these, and any help is much appreciated when I'm grading. At the bottom of this page, I just typed a couple techniques to keep in mind. There's no specific order to these. These are literally just helpful tips. So there's 4 helpful tips. However you read them, however you approach them is up to you. The first tip is to rewrite expressions in terms of sine and cosine. I say that because I feel like it's easiest to simplify sine and cosine. There are alternate methods, but sine and cosine are the easiest to deal with. My second tip is to find a common denominator if that is a possibility. So if you're adding or subtracting fractions, you probably want to think about a common denominator. My third tip is to factor expressions. If you can take out a GCF, or if you can factor by grouping, if you can somehow separate some terms, try to do that. And my fourth tip is to use identities, which are all the identities we went over yesterday, to replace expressions.